Okay, let's get started. Well, thank you everybody for attending this morning. This is the first part of a 3 series that we'll be giving as a lunch and learn. First, I want to introduce myself. My name's Lisa Sercombe. I am a product manager here at Millennium Science, and specifically what I work with are the detection and liquid handling instruments with Agilent BioTek technologies. And so Agilent BioTek are known to create high quality, dependable plate readers that are built to last. So today what I'm going to be talking about is the technology that powers these instruments and their applications. So first topic to begin with are the hybrid multi-mode readers. So the hybrid multi-mode readers is really where especially the biotech instruments shine. It's the best of the both worlds. You have instruments with monochromator based optics, which give you convenience and flexibility to be able to dial into any one wavelength, in combination with filter-based optics, which use high bandwidth filters for exceptional sensitivity. And so instruments with this hybrid detection modes really have huge application flexibility. And so they allow you to perform essentially any microplate assay. And there's 3 examples of instruments with this patented hybrid technology, which BioTek is known for. The Synergy H1. And the Synergy H1 has all of the flagship detection features of BioTek and taking it to the next level. They have a new filter cube design, which allows for greater applications flexibility and speed. We also have being able to change the Z height for optimal readings within the well, along with an extended dynamic range of the Synergy H1. So for superior sensitivity of this instrument here. In addition to the H1, we have the Neo 2, and the Neo 2 took the success of the H1 and then added that next level. And it was built in mind of the pharmaceutical market because it really does have uncompromised speed and sensitivity. That being said, the Synergy Neo 2 is modular and upgradable. So you can build this instrument up or down to meet your needs. So it's accessible to commercial, pharmaceutical, academic labs alike. And lastly, the Citation 5. And the Citation 5 uses the combination of your hybrid-based optics, as well as it can be built with an inverted microscope. And a really unique feature of the Citation 5 is this hit picking that you can see here. And thanks to hit picking, you can detect your areas of interest and simply image those wells. So this is going to save you a significant amount of time and also data storage. So looking into the Neo 2 specifically, so the Neo 2 uses 3rd generation quad monochromator designs for its fluorescent monochromators. And these have variable bandwidth settings between 3 and 50 nanometers in 1 nanometer increments. And the advantage of this variable bandwidth is with large bandwidth settings, you can provide increased sensitivity and lower limits of detection. And with small bandwidth settings, you'll have increased specificity when you have multiple signals, and this will reduce signal crosstalk and enhance your assay performance. So why is this variable bandwidth setting important? Well, many fluorescence dyes and fluorophores can have a narrow Stokes shift. And that is the difference between your excitation and emission and maximum. And so you can see an example here of many common commercially available fluorophores that have a very narrow Stokes shift. So without a variable bandwidth, what you need to do to detect these fluorophores is actually set the excitation and emission on the shoulder of the peaks. And the resulting quantum energy means less excitation light and consequently less emission light, which is going to compromise the sensitivity of your assay. In contrast, with your variable bandwidth settings, and this is an example for a multiplex assay, you can customize specifically where you're going to set your excitation and emission for your assay. We can see here with multiple signals shown through these colors here for a multiplex, as well as a FRET assay as well. So in addition to the monochromators available for your application flexibility, there's also an extensive library of filter cubes available. And this is just an example for the Neo2 itself. And this allows you for ultimate application flexibility from fluorescence intensity, filtered luminescence, alpha screen, fluorescence polarization, and time resolved fluorescence. And this is just an example of some of the filter cubes that are available. But it's not just limited to these cubes here. There is a library of customizable filter cubes for any niche applications that you should choose to look at in your laboratory. In combination with the high performance of the filter system, there's also multiple detectors which can be built into the Synergy Neo 2. You can see here, you can look at with ratiometric measurements when you're having two signals, you can dedicate a PMT to each of those. So what's the advantage? My apologies. So what's the advantage of having dual PMTs? Well, with other systems, when you're wanting to perform assays such as fluorescence polarization, TRF, and so forth, you have to measure these results one at a time, and this is going to considerably lengthen the time to get to results. With the Synergy Neo 2, you can read these two separate measurements separately, but also simultaneously. This is going to be significantly faster. This is highly important for your ratiometric measurements, such as your BRET, TR FRET, fluorescence polarization, and so forth. You can also build in dedicated laser-based detection in the Synergy Neo 2. An example is you can have an alpha-based laser. It's a 100 milliwatt laser. And this is going to give you superior sensitivity and fast read speeds for your alpha screen, LISA, and plex assays. You can also utilize a TRF laser. I'm just looking into the Synergy Neo 2. This laser is a 337 nitrogen laser, allowing you to perform TR FRET, HTRF, laser screen. And looking at the Z prime here, you can see the true power of using pause that there. Anyway, you can see a true power of utilizing a TRF laser as compared to a xenon flash light. And you can see through this image here, we have compared to a xenon flash light and a laser for TRF, we have a significant sensitivity and speed. So the advantage of utilizing the hybrid optics within and the Synergy Neo2 example is that you can utilize a diverse range of labeling strategies to answer your question of interest. So in this example here, looking at kinases, you can use a traditional absorbance phosphoELISA, an alpha screen kinase assay, a luminescence assay such as ADP Glow, and a time resolved fluorescence assay such as the Adapter universal kinase assay. So utilizing 4 unique detection strategies to really tease apart your question of interest. I also wanted to utilize this slide here to show you an example of the true application flexibility of the Synergy Neo2 as well. There really is a whole host of options, and thanks to the fact that the Synergy Neo2 can actually provide incubation up to 70 degrees, it has a new application that you can perform on this instrument known as lamp assays. So the next range of these detection instruments with the Agilent BioTek is known as multi-mode readers. And there's really 3 categories here, and how they're defined is using dual optics with monochromator-based absorbance and filter-based fluorescence. And the Synergy HTX, the first one I want to talk about, it is one of our most common microplate readers. It is a true workhorse for any lab because it will cover and enable you to perform your assays that any standard lab should need to perform. And also go up to incubation to 50 degrees. The citation range is another example of our multi-mode readers, and there's 2 examples of the citation instruments that fit in this category. The Citation 7, visualized here, has a upright microscope as well as a inverted as well. And so this was really performed and built to allow you to perform ELISpot assays, and it was designed for the immunology market in mind. The Citation 1 is a pared down version and is similar to the Synergy HTX, and a interesting functionality of the Citation 1 is that it can be conjugated to the seahorse to allow you to look at your metabolic assays as well. Lastly, the Synergy LX, and the Synergy LX is the newest generation of the multi-mode readers, and it was really designed to fill the gap to be an entry-level multi-mode readers. It doesn't have all of the bells and whistles, but it does allow you to have high quality detection. So looking a little bit under the hood, if you would, the Synergy LX uses fiber-free optics, and this is going to limit stray light and a superior sensitivity. An example of one assay that you can perform on a myriad of the BioTek instruments, but wanted to provide an example here, is the Take 3 plate. And the Take 3 plate really allows you to perform microvolume analysis and quantification of DNA, RNA, and protein using a high quality instrument through your multi-mode readers or your absorbance. And you can actually utilize the Take 3 plate for both absorbance and fluorescence quantification. And it's a very simple and easy protocol. It's simply adding the samples to your microdots, your working reagents, and the protocols are all inbuilt into the Gen 5 software. Something that I wanted to quickly take a note is that Millennium and Joma also provide dyes through BioTek, and BioTek has a whole host of fluorescent dyes, which are high quality. And we have ones that are equivalent to those who are used to using your qubit assays. You can also perform the quantification with the Biotium equivalent dyes in our systems, and they are high quality dyes that are incredibly stable. Next, we have the absorbance readers. And there's really two predominant classes of absorbance readers that BioTek provides. We have our filter-based optics and our monochromator-based optics. The filter-based is known as the 800TS, and this is essentially the ELX 800. It has the same workhorse technology as this instrument, which BioTek has been known for. And these instruments are high quality, built to last. We have instruments for the EL 800, which have been in the field for about 20 plus years and are still going strong. The 800TS, like I said, has a facelift, so it has a wonderful, really convenient touchscreen for really easy protocol editing and instrument performance as well. With our monochromator-based optics, we have the Epoch 2. It's a really small scale portable plate reader, which is powered through the monochromators. It is very compact, and you may not be able to visualize it from the slide here, but it's about a microplate and a half. The other one we have is the Epoch 2, and the Epoch 2 is the next generation of the Epoch. It has all of the great features that the Epoch is known for, but just taking it up another notch by adding shaking capabilities and incubation, allowing you to perform kinetic assays on this instrument. We also have the added flexibility of a cuvette port in the Epoch 2 as well. Lastly, the final instrument I wanted to touch on was the LogPhase 600 microbiology reader. And this reader was designed with the pharmaceutical market in mind. Sorry, just having slight technical difficulties. Okay, that's okay. I will continue without this video here. So it was designed specifically with the microbiology market in mind. And you can see this in the design of the instrument itself. It's the only 4-plate microplate reader on the market. It's also built in with industrial strength motors to power continuous shaking for the instrument, and no other plate reader can stand up to this task. In fact, when BioTek was doing the QC for the LogPhase 600, they continuously ran this instrument for 15 months with 0 failures. The incubation of the instrument has been specifically designed for continuous uniformity for each plate, and this will ensure you have continuous results. And so with this information in mind, the LogPhase 600 fits in nicely with both your industrial and academic researchers alike. So in summary, whether you have a need for a very application-specific instrument, looking to perform a subset of applications within your laboratory, or you're looking for advanced levels of detection or even future proofing, BioTek really does have a solution for your needs. And all of these instruments are built with high quality, dependability, and long-lasting technology that BioTek is known for. Okay, well, that is me in a nutshell. I wanted to thank everybody for coming to this webinar and learning a little bit more about the applications and technology that is behind the Agilent BioTek range. I've just provided some information on the screen about the websites where you can get more information potentially. And if anyone has a question, now is your opportunity.